Hello, myself Akash Reddy from SPCA College. So today's topic is CNN architecture. So at first, let's go through the introduction of CNN. CNN is a type of deep learning neural network designed for processing a structured grid data such as images. CNN are widely used in computer vision tasks using OpenCV module in Python such as image recognition, data recognition, object detection, and image segmentation. The architecture of a CNN typically consists of conventional layer, pooling layer, and fully connected layer. Conventional layer are a building block of CNN and responsible for extracting features from the input data. The output of a conventional layer is called a feature map, which represents the presence of different features in an input image. At first, let's go through what is conventional layer. There are three types: input layer, hidden layer, output layer. At first, let's go to the input layer. Input layer, it's a layer in which we give input to our model. The number of neurons in this layer is equal to a total number of features in our output data. Hidden layer, the input from the hidden input layer is then fed into the hidden layer. Then we call many hidden layer depending on our model and data size. Each hidden layer are different number of neurons which are generally greater than number of features. The output from each layer is computed by a matrix multiplication of an output from of a previous layer with the learnable weights of a layer, then by additional learnable bias followed by activation functions which makes the network non-linear. Output layer at last. The output from the hidden layer is then fed into the logistics function like softmax, which converts the output of each class into a probable score of each class. CNN architecture. The conventional layer applies filter to the input image to extract the features. The pulling down sample to reduce a computational and fully connected layer which makes the final prediction. The network learns the optimization filter through backpropagation and the gradient descent algorithms. Pulling layer are then used to down to sample the features maps generated by a conventional layer. Common pooling operation include a max pooling and average pooling, which reduces the spatial dimension of feature maps. Pooling helps to makes a network more robust and to the variations in which input data and reduces the computational complexity of a network. In the image, we can see at first we have conventional layer one kernel valid padding, which is a input, which is written to. Next we have N1 channel, max pooling. Next we have convention 2, and so on it goes. And at last it has a fully connected neural network, which gives our output. How a conventional layer works. Conventional neural network converts that shares the parameters. Imagine you have an image. It can be represented on keyboard having its length with a dimension and a height. Now imagine taking a small pitch of this image and running it a small neuron network called a filter or a kernel on it, which says k output of a representing them vertically. Now slide the neural network across the whole image. As the result, we get another image with a different width, height, and depth. Instead of just RGB channel, now we have more channels but lesser width height. This operation is called conventional. If the patch size is the same as of the image, it will be regular neural network, also known as RNN. Because of this small patch, we will have fewer width. In the image, you can see the input data, then into the conventional layer, pooling layer, conventional layer, pooling layer, and fully connected layer, and the output. And the next we have you can see how the network is going to be built. The CNN are trained on a large dataset using backpropagation and a gradient descendant. The model performs it evaluated on a separate test set to measure accuracy and generalization. Techniques like data augmentation and transform learning can enhance the performance of a CNN models. Layers to build a convolutional, which is a CNN model. A complete CNN architecture is also called a convolutional. A convolutional is a sequence of layers, and every layer transforms one volume to another through a differentiable functions. There are different type of layers. At first, we have the input layer. It's the layer in which we give input to our model. Next, we have the conventional layer. In this layer, which we use the extract the features from the input dataset, it applies a set of learnable filters known as kernel to the image. The filter kernel has smaller matrix, usually as 2 cross 2 and 3 cross 3 or 5 cross 5 slide shapes. It slides over the input image data and computes a dot product between a kernel weight and a corresponding input image. The output of this layer is referred as a feature map. Suppose we use a total of 12 filters layers, we will get output volume of dimension 32 cross 32 into 12. Next we have the activation layer. By adding activation functions to the output of a prediction layer, activation layer add a non-linear to the network. It will apply an element-wise activation functions to the output conventional layer. Some common activation functions are ReLU, max, tanh, and leaky ReLU, etc. The volume remains unchanged, hence the output will have a dimension 32 cross 32 into 12. Next, we have the pulling layer. This layer is periodically inserted into the convention, and its main function is to reduce a pulling of a value, which makes the computation fast, reduce memory, and also prevent overfitting. Two common types of pulling layers are max pulling and average pulling. It will use a max pulley of 2 cross 2 filter and stride 2. It resets the volume will be dimension of 16 cross 16 cross 12. This is the complete input hidden layer and the activation layer. And next we have the output layer, which is showed in the image. At first we have the flatter layer, fully connected layer, and soft max layer, also known as output layer. Advantages of CNN: good at detecting patterns and feature extracting features in the image, video, and audio signals. Robust to translation, rotating, and scaling invariants. End-to-end training, no need for manual feature extraction. Can handle a large amount of data and achieve a high accuracy. Next, we have the disadvantages: computationally expensive to train and require a lot of memory. Can be prone to overfitting if not enough data or a proper regulation is used, require a large amount of labor, interpretability is limited, it's hard to understand what the network has learned. Next, we have the applications of CNN. CNN has numerous applications beyond the image processing, image recognition, and object detection, and facial recognition, and medical image analysis. They have been used in autonomous vehicles, surveillance system, and natural processing, also known as NLP. CNN continue to drive advancement in AI and are a key technology in DL, deep learning landscapes. In conclusion, CNN architectures have evolved over the years from a simple model like LeNet5 to deep network like RESNet. Understanding the components of CNN architecture such as conventional layer, fully layer, and fully connected layer is essential for designing an effective network. By leveraging the power of CNN, researchers and precautioners continue to push the boundaries of computer vision and AI